Okay, so here's our second example of using algebra to study something we're interested in. And in this case, the example comes from political science. And it comes from a puzzle about pork barrel spending. So pork barrel spending, sometimes people call it distributive politics, right, just call it infrastructure spending. What we're talking about here are government bills that involve projects where the benefits of the project are largely experienced in a local area. So it's a highway bill, it's a bridge, it's having the harbors dredged, it's some kind of a public works project where the people who benefit from it are the people in some kind of area. So the way we would say this is that the benefits are concentrated. They're concentrated on a small subset of the population. The costs, on the other hand, are diffuse. These projects are funded out of general tax revenue. The whole country pays for it. So thinking about pork barrel projects is interesting because the coalition politics are kind of provocative. So the puzzle comes from a disjuncture that Barry Weingast, whose article this is taken from, that Weingast observed kind of in the 1970s. So at that point, political science was starting to make use of formal theory, mathematical models, and the theoretical prediction about these kinds of bills is that they should be minimum winning coalitions. Okay, so theory predicts MWC, minimum winning coalitions. Okay, so the idea behind this theory is if you're going to build a coalition for pork barrel projects, everybody wants benefits for their district. Okay, so everybody wants to have a project that they can experience the benefits for, but they want to pay as little cost as possible. So once you have enough people in your coalition, enough legislators in your coalition, enough districts represented in your coalition that you have a majority, then you've got enough votes to pass the bill. Why would you add more people, more legislators, more districts, who are just going to increase the cost of the bill, and you, as somebody who is already included, you're not going to get any of the benefits? Okay, so this theory of minimum winning coalitions is a theory of, sort of rational choice in kind of a very narrow, stingy, self-interested way. So nonetheless, there's lots of narrow, stingy, self-interested behavior in politics. And here is a pretty solid theory predicting that these coalitions should be small. That is not what empirical scholars were observing. The people who studied the US Congress in this time noted kind of the other extreme, that this kind of bill, these kinds of spending bills, not just had more than a minimal majority, they tended to be universal. Okay, so empirical scholars would talk about norms of universalism. And that was sort of how they explained their findings. They would say, yeah, you rational choice people, you think that everybody's so self-interested. We, the people who observe Congress, we're here to tell you that that's not how the members of Congress act. They have norms that they observe, and their norms say that everybody gets a project. Okay. So Weingast wants to challenge this juxtaposition, and in challenging it, he wants to propose a solution to the puzzle. So his argument is that minimum winning coalitions are maybe not the most rational thing for a legislator to want, because until you know that you're included in the bill, you don't know whether you're going to be voting for this great bill that gives you a nice juicy project for your constituents. It doesn't cost that much because it's only giving projects to enough districts to get a majority. So that's one thing that could happen if you're in the minimum winning coalition world, or you could be in the minority. You could be left out. You could be one of the legislators who's voting against the bill, not getting a project, not getting any benefits, but still paying your share of the costs. So what Weingast is going to argue, and what we're going to show with algebra here, is it's actually in legislators' self-interest to be in a world of universalism, in a world where it looks like everybody's following morals and going against their self-interest, that it's actually more rational to want to be in that world than to be in a world where, yes, you might get the bigger payoff from being included in a minimum winning coalition, but you run the risk of getting the very low net benefits of being part of the excluded minority. So that's what we're going to look at here. And to do that, we're going to define some variables to represent the things that are part of the story. So we're going to have B equals B representing the benefits of each project. And as we noted, they are concentrated in a single district. Okay, so we're just going to really focus on this logical puzzle. We're going to think about each project's area being a congressional district. And C is the cost of each project. And again, just to kind of keep things simple, we're going to assume that each project has the same level of benefits, each project costs the same thing, and the costs are spread evenly over each district. We're going to assume that there are n districts represented by n legislators, and just to keep things simple, we're going to assume that n is an odd number. What might not be so obvious, but I hope you'll follow me in seeing, if we have n an odd number, n plus 1 is the smallest possible majority. That's the size of a minimum winning coalition. If you want to pass a bill in a legislature with n seats, you need to have at least n plus 1 over 2 votes. Okay, so just to make sure that this is concrete, first let's think about the fact that if n is odd, then n plus 1 is even. Okay, n plus 1 is divisible by 2, and so that's going to give you an integer here. And because it's more than half, it will be enough to pass the bill. Another way to see that this makes sense is to just plug in some numbers, and that's always a good strategy for wrapping your brain around how variables are used to represent things in the real world. So just kind of thinking here, if we have 5 people in our legislature, well, what's n plus 1 over 2 if n is 5? It's 6 over 2, it's 3, and indeed that is the minimum number of people you need for a majority. If we're talking about the US House of Representatives, n is 435, n plus 1 over 2 is 436 over 2, and that is 218, which is the magic number in the House of Representatives. So that is the size of the minimum winning coalition. Okay. So what we want to do now, just getting that set up, we want to compare for a given legislator, a given district, you can think about it either way, compare the total value, that's benefits minus benefits experienced minus cost paid for 2 types of bills. We're going to compare the value of universal bill to the value of a minimum winning coalition bill. Okay. So let's do the universal bill first. That's pretty easy. There's a universal bill, and I'm just some random legislator. Yes, my district's going to get a project, so I'm going to get benefits B. Yay. And I'm going to pay my share, 1 over n, the costs are being spread over all the districts, of projects that cost C. And how many projects do we have that cost C? Well, we have n of them. That's what it means to be universal. Here, everybody's getting a project. And that just reduces to B minus C. Okay. So if everybody gets the same project and pays the same share of the costs, basically I get the benefits of my project and I get the equivalent of the costs of my project. But if we're in the world of minimum winning coalitions, here my guess main idea is coming in. We're in a world of uncertainty. We don't know whether we're going to be included in the bill or whether we're going to be excluded. Okay, so if we want to think about the value to us of a minimum winning coalition, we got to think about it as a random variable, and surprise, surprise, we've got to calculate its expected value. Okay, so we need to think about this as a random variable where we'll let V1 be the value if I am included. And V2 is the value of that bill if I'm excluded. And P1 is the probability that I'm included. P2, the probability excluded. Like always, those probabilities are going to sum to 1. Fine. But if we can come up with expressions for each of these parts of the random variable here, then we can calculate the expected value of the world of minimum winning coalitions. Same way we calculated it in the last lesson. It's going to be P1 times V1 plus P2 times V2. Okay. So that's what we're going to do going now to the next page. We're going to figure out the value of a minimum winning coalition to the person who's included, the probability of being included, the value of you're excluded, the probability of being excluded. And then we're going to be able to compare this expected value to the value of a world of universalism where there's no uncertainty, where you know you're going to get B minus C with probability 1. So that's where we're going. All right, so let's start with the first thing that we're looking for. V1 is the value if included. So if I'm included, I get my project B, and I still pay my share of the costs. And the costs are still being shared over all n districts. Everybody in the legislature pays their constituents pay their share of the costs. And each of the projects still costs C, but there's not as many projects now. Okay, how many projects are there? Well, there are just enough to have a minimal majority. Okay, so this is the number of projects, just enough projects to get minimal majority. Okay, so this is the smallest possible majority. And what if I'm excluded? Well, it's pretty much the same except no B, right? No B for me. I didn't get a project. Boo. I still have to pay my share, my district's share of the costs of those n+1/2 projects. I'm not in that n+1/2, but I'm still paying. Okay, so there's a negative sign here. Okay, so those are our two outcomes. We're marching through the things that we need to calculate expected value. What is the probability that I am included? Okay, we're going to assume it's just completely at random. Okay, so we are going to choose the number we need, n+1/2. We're going to choose that minimal winning majority out of a total, out of n possible. So every member of the legislature has an equal chance of being selected here. So what's the probability that I'm selected? Well, it's not quite 50-50 because it's a little bit more than 50-50 because what we're getting is a little bit more than 50% coalition here. So just writing that in maybe a somewhat nicer form, the probability that I included is n+1/2n. P2 probability that I'm excluded. One easy way to calculate that is just to remember that P1 and P2 have to sum to 1. So that is going to be 1 minus the probability that I was included here, 1 minus n+1/2n. Putting that over a common denominator, I get 2n minus n minus 1. Notice I'm being careful because this negative sign is applying to the entire numerator there. Divided by 2n. And so what I get here is 2n minus n is just 1, I'm left with just 1n and still the negative 1. Minus 1/2n. Okay, so I think I'm going to start a new page here. And while I'm starting a new page, here comes the algebra. So now is a really good time if you have not been taking notes with pencil and paper to make sure that you get them out and to make sure that you are following these steps. Okay, so with what we just did, the expected value of the minimum winning coalition bill is the probability that I'm included in the minimum winning coalition. So that's n+1/2n times what I get if I'm included. I get my B and I pay my share of the costs of n+1/2 projects, each of which costs C. Or I am excluded, and the probability that I'm excluded is n-1/2n. And what do I get if I'm excluded? Well, I don't get the B, but I still pay my share of the cost of n+1/2n projects, each of which costs C. So this is kind of putting together a lot of stuff. Let's make sure that we're seeing what everything is here. This is the probability that I'm included. This is what I get if I'm included. This is what I get. This is the probability that I'm excluded. This is my V2 here. And in picking apart the components of the costs here, we've got each legislator's share is 1/n of the total cost of n+1/2. That's how many projects we have. Each project costs C. Okay, so that's a little messy, but that's what we learned algebra to do. Simplify things that look messy, make them look less messy. And as you might remember from the Unit 1 videos, sometimes to make things less messy in the long run, we have to make them a little more messy in the short run. So we're going to start doing some rearranging here. And looking at this, I think what I'm going to do is put the terms that have C together. So I'm just going to leave this n+1/2 over 2n b there. But now I'm going to separate out n plus 1 over 2n. Okay, I've got n plus 1 over 2n here, multiplied by the negative of the same thing. I've actually got n plus 1 over 2n squared times c. So what I'm doing here, this factor times this factor. I've got the negative. They're actually the same when you consolidate them. So I've got n plus 1 over 2n squared minus c. That is this term here. And I've also got, bring that back. Let's look at what we've got going on in here. Well, we've got a negative sign there, so we're going to have a negative out front. And we've also got this 2n squared in the denominator. So let's put that there, making sure that we're getting the parentheses right. And in the numerator, we don't have n plus 1 squared. We have n minus 1 times n plus 1. And that whole thing multiplying c there. Okay, that is what it is. Just checking that the negative signs all line up, the squares all line up, that we've got everything. Looks pretty good. Fine. I can factor out the c. The other thing that you might be noticing is I can factor out n plus 1 over 2n, and that's what I'm going to factor out. You might be thinking you could factor all sorts of different ways. You're right, you could, but this is the way I'm going to do it. So continuing to just recopy the b term. It's kind of here not doing much. I'm factoring out n plus 1 over 2n c. And then what am I left with? Okay, so in this term, I have two factors of n plus 1. I factored out one of them, but I'm left with the remaining plus 1 over 2n. Okay, so that's taking care of the fact that it's squared here. I'm putting one there, one there. And then for the other term, now notice here, I've also factored out the negative sign here. So I've got this negative sign here and here accounted for. So what it means is I've got the remaining factor, and my other remaining factor is n1. It's not n plus 1. It's n minus 1. N minus 1 over 2n. Okay. Again, let's just check and make sure that I've factored everything correctly. So two terms, still got two terms. There's a c in both of them, fine. There's one factor of n plus 1 over 2n here and 1 here. So that also factors out. Once I take out one factor of the n plus 1 over 2n, I'm left with another one. So that's here. And I'm also left with n minus 1 over 2n. And I had a minus sign, a negative sign hitting both of them. I factored that out as well. And so this negative sign is applying to both of them. It means it's a positive sign inside the parentheses. Okay, that was a lot of algebra just in those two steps. So maybe take a step back and admire that. Okay. Now it looks like it might start to get simple again. So let's just keep going here, sticking with B term, it is what it is, minus the stuff I factored out, n plus 1, 2n times c. Here, wow, how nice, we've already got a common denominator. That is just great. It's 2n, and what do I have? I have n plus 1, it's 2n, plus 1 minus 1 is 0. Oh, I have 2n over 2n. That equals 1. Right? Well, that's convenient, isn't it? So I've got n plus 1 over 2n b minus n plus 1 over 2n. C, oh, look, it's the same thing. I can factor it out. So now I've got something that looks kind of reasonable. N plus 1 over 2n minus c. Okay. That is my expected value. Let's zoom out a little bit and remind ourselves why we went through all this algebra. We wanted to know if, taking account of the uncertainty in the world of minimum winning coalitions, what the expected value of a world where those bills are going to have as narrow a majority as possible. We're going to have narrow majorities to save on the costs. That's great for the people who are included. It's worse for the people who are excluded. How can we compare that to the payoff from universalism? Now we can. We have the expected value that lets us do the comparison. So let's just write them both down here. So this is the expected value of the world of minimum winning coalitions. This is the world where we're ruthless and rational and self-interested and all of those things that political scientists at the time were saying were different than following norms and being considerate of your colleagues and all of that. What Weingast says is, well, if we compare how we do in this world that's supposed to be driven by maximizing the legislature's net payoffs, compare that to what they get in the world of universalism, E minus C, this is actually a bigger number. Let's look at the term that is multiplying B minus C in the expression for the expected value of VM. What is that? Okay, this is a fraction greater than 1. Sorry, a fraction less than 1. Sorry about that, right? This is the size of a minimum winning coalition. This is 50% plus something. These were numbers like 3/5, 218 over 435. These are numbers that are always less than 1. So let me write down the point that really matters here. This is less than 1. Another way to look at it is it's the ratio of the size of the minimum winning coalition, that was the n plus 1 over 2, to the total. But the important thing is that this is a number that is less than 1. So whenever we're in a world where we want to do this in the first place, whenever the projects are themselves worth doing, B greater than C, the payoff from the world of universalism, the payoff from following norms, is higher than the payoff, the expected payoff from the minimum winning coalition. Okay. So again, you might read the Weingast article in a class that you take in grad school. I think there's several classes that have assigned it over the years, and I wouldn't be surprised if they still do. And in that context, there's lots to talk about there. For what we're interested in here, I'm basically, the thing I care about is, can you follow this argument? Okay, can you follow the algebra that it took to get from the definition of the expected value of this variable, just plugging these expressions into the expected value, to this expression for the expected value, the simplified version of it, that we could compare to the value of universalism and say, look, whenever we have projects where the benefits are higher than the costs, you would rationally prefer to be in the world of universal norms rather than the world of short-term rationality, you might say. So again, in a class where we were interested in the substance here, we might sort of notice that big picture argument. The big thing that Weingast is saying, and he's saying it not just to congressional scholars, but to political scientists in general, is that there are better definitions of self-interest than very narrow, short-term, context-dependent self-interest. Once you start allowing for some kind of uncertainty, then behavior that looks like it's being driven by altruism and morals, and it may well be experienced as altruism and morals, can actually be in the enlightened self-interest of the legislators that in this case would be following the norm of universalism. That argument is not new to Weingast. If you've read some political theory, you might recognize it as being part of John Rawls's theory of justice. Lots of people think they see this argument in Kant's writing from the 18th century, so it's not, Weingast is not the first person to observe that doing things that seem altruistic can be beneficial from a broader perspective, that rationality and morality are not necessarily opposites or antagonists. But that certainly was a point that congressional scholars had been missing. So he sort of brought this idea into a new context. And I guess maybe I'll just end this video by saying that's one of the great things that mathematical modeling can do for political science, for social science in general. It can help us see how specific problems that we are interested, because we are specifically interested in Congress and who's getting projects and things like that, how these specific problems that we're motivated to study fit into broader theoretical schemes with sort of broader morals here. And that's what we were able to see in this case. Okay, so the downside of any kind of mathematical model, any kind of model at all, is to get to a point where you can compare something as simple as the expected value of one random variable to another variable. You've got to make a lot of simplifying assumptions, and Weingast made a lot. Some of them might be bothering you. In the workshop associated with this lesson, you'll get a chance to work through a version of this model with some of the assumptions changed. So we'll see you then.